Okay, but the point in any case is that this is a pattern that is actually more general. There are more general things that we would like to do than just take the lines. Here's an example. We might have a list which is comma-separated, a comma-separated list of items. We might want to split that into a list of items. So what would that look like? Well, that might be a function comsep, which takes things which are up until the first comma and then drops them, so something like that. So if I do a not compiling, comsep, not commasep, on that example there, then it splits it into the words that are in between the commas. Okay, so what is the general pattern here? Well, the generalization we make is to generalize over the test that we're performing, and let me do it on the slide, is to compute the segments of the list. So this would be a way of generalizing it, and it turns out that this is quite useful but not a standard function. It just generalizes it by lifting out the property and making it an argument. So you take while the property holds, throw away the element that failed the property, throw away the first segment and the element that failed the property, and recursively continue. So then lines could be defined as segments of things which are not equal to the new line. Okay, so you see the pattern. The need for a higher order function arises when we have repeated patterns of computation, and higher order functions are very often the natural way to generalize. Sometimes the generalization is just to lift out other kinds of data, not functions, but very often functions are a very natural way to generalize a computation. And that's a message that you can take home to your other favorite programming languages. Providing they have enough expressive power, you can do similar kinds of abstraction tricks in modern C++, in your JavaScript, in whatever.